students, welcome back to my another lesson. So today we will be discussing some important numericals from lesson 2, that is units and measurements. And remember, I am discussing only some frequently asked questions that may be going to come for the coming board examination. Okay, without wasting time, let me go into the first question. The period of a simple pendulum is given by t equal to 2 pi root L by G. The percentage error in L is 1% and that of t is 2%. What is the percentage error in G? That we have to calculate. Okay, so this question is very simple. Don't worry. Let me write the equation once again. So t is equal to 2 pi root of L by G. L is the length of the simple pendulum, G is the acceleration due to gravity. So let me square this equation on both sides. So I will have t square. T square is equal to 4 pi square L by G, because root has cancelled by the squaring the equation. So let me cross multiply this equation. So G equal to 4 pi square into L by t square. We have this equation. Now let me see the percentage error. In order to calculate the percentage error in G, we must consider the percentage error in L and T. But here the percentage error will be coming as in the form of a combination. That is, here we have two important things. One is the ratio, that is we have a ratio of L and t square, and t square is actually the in a powered form, that is the second power of t is given. So we have division and power of a variable also. So the combination error has to be used to find the total percentage error in G. So that is very simple. That is, the total percentage error in G will be delta L by L into 100 plus delta T by T into 100. Why I have taken addition here? Because even if the equation is L by t square, we have to take addition while multiplication and division. So delta L by L into 100 plus delta T by T into 100. That is the equation. But here we have some other thing also, that is delta T by T is actually the percentage error, but the percentage error is of a square. So I have to rewrite this equation like this: delta L by L into 100 plus 2 times of delta T by T into 100. Why? Because t has a power 2, so 2 times I have to include. Suppose t has a power of 3, then you write 3 times. If it is a 4, then write 4 times. That's the thing. It's a simple thing that we have already studied in theory. So delta L by L into 100 is the total percentage error in L. So which is given as 1 plus 2 times of delta T by T into 100 is the total percentage error in T. So which is given as 2. So in total, our final equation will be 2 into 2, 4, 4 plus 1 is 5. So 5% is the total. Okay, let me go into the second question. So you can see the second question. Which of the following length measurement is most accurate and which one is most precise? The first is 800.0 B. Second question is 0.008, and third question is 8.0 millimeter, and fourth is 0.08 millimeter. So we want to find two things. One is most accurate value and most precise value. You may be confused the difference between accuracy and precision, but in theory we have studied what is accuracy and what is precision. Okay, so let me write this all A, B, C and D in relative error format. That is the first, that is 800.0 I can write as the relative error, that is delta L by L, where L is the length, which is already given the length measurement. So delta L by L I am writing as 0.1 divided by 800. L is 800. So why 0.1? Because after the decimal we have only one value which is given as a precision. So 0.1 divided by 800. So similarly, second B, I can write it as, this is A. So B I am writing B as a 0.008 meter. So I can write it as again delta L by L, which is equal to how many decimal values? 1, 2, 3. So I can write it as 0.001 divided by 0.008. Similarly, C, I can write it as C is 8.0 millimeter. So 8.0 millimeter, that is also delta L by L. So delta L by L is the relative error, so which I can write it as 0.1 divided by 8.0. Okay, because after the decimal point we have one place value, so 0.1 divided by 8 I can write. So finally the CD I can write it as 0.08, which is given, that is delta L by L, which is equal to 0.01, because after the decimal point we have two values. So 0.01 divided by 0.08. So we will do this one, that is 0.1 divided by 800. So how can we do? This is simple, 1 divided by 8000. Similarly here it will be, we have to multiply these numbers just to cancel the zeros. So this can be written as 1 divided by 8000. Similarly this can be written as 1 divided by, I have multiplied with 1000, 1 by 8, and this can be written as 1 divided by 80, and the last quantity is 1 divided by 8. So 1 divided by 800 will be, 1 divided by 800 will be that is 1.25 into 10 raised to minus 4 will come, 10 raised to minus 4. And for this 1 divided by 8 is 1.25 into 10 raised to minus 1 will come, 10 raised to minus 1. And for C, 1 by 80, it is just 1 power of the first quantity, less power of the first quantity, 1.25, same, that is 1.25 into 1.25 into 10 to the power of minus 2 will be coming. And similarly here it will be 1 by 8, which is similar to the second, 1.25 into 10 raised to minus 1 will be coming. Okay, now just to see, we will compare all these quantities, 1.25 into 10 raised to minus 4, 1.25 into 10 raised to minus 1, 1.25 10 raised to minus 2, 1.25 into 10 raised to minus 1. These two quantities B and D are same quantity, so you don't want to worry about. Anyway, since the relative error in the minimum in the measurement is at A, here you can see 10 raised to minus 4 has the minimum value. Power has the lowest power. So we can write the measurement in A will have the most accurate value. So 1.25 into 10 raised to minus 4 will be the most accurate value because it has the minimum measurement. And the measurement D, you can see measurement D is most precise because it is taken with an instrument of least count 0.01 millimeter. 0.01 millimeter. Here all the things from the question itself you can see this is 0.08 millimeter, and rest of them all are coming like 8 millimeter, like that, 0.008 meter and 800.0 centimeter, like that. So we can avoid that. So the precise value will be the last value 0.08. Okay, come to the third question. Our third question is, write the dimension of A by B in the relation F is equal to A root x plus B t square, where F is the force, x is the distance and t is the time. So this is also a general question. So answer is also given the right side. Anyway, we will try to do this question. So let me write the equation F equal to A root x plus B t square. And what are the things given? F is the force, x is the distance and t is the time. T is the time. That is also given. Okay, so how to do this question? It's very simple. We will compare the dimensions of LHS and RHS. So here in RHS we have two terms. So as per the principle of homogeneity, we have studied the dimensions of LHS. Dimensions of the LHS should be equal to the dimension of each term of the RHS. So here you have A root x. So what is its meaning? Meaning is very simple. That is, dimension of F must be equal to the dimension of A root x. Similarly, the dimension of F must be equal to the dimension of B t square. That is its meaning. So let me take this and compare it. Now the dimension of F, I am writing it as dimension of F. Dimension of F, you know, F is the force, so F is equal to ma, so which is equal to m L t raised to minus 2. That we have already studied. So let me write m L t raised to minus 2 equal to this equation, A root x, the dimension of A root x. So x is the distance which is already given in the question. X is the distance. So root x means L raised to 1 by 2. L raised to 1 by 2. So we need to find the dimension of A. So dimension of A I can calculate like m L t raised to minus 2 LHS divided by L raised to 1 by 2, which is equal to the dimension of A. Just a cross multiplication. Okay. So L raised to half will be L raised to minus half when it goes up. So I can write it as m L t raised to minus 2 numerator, then L raised to minus half, which equal to m. Here you can see that power of L is 1 and here the power of L is minus half. So 1 minus half is half. So m L raised to half t raised to minus 2. M L raised to half t raised to minus 2. So m L raised to half t raised to minus half is the dimension of A. But in the question they have asked us to find the dimension of A by B. So that means we want to find the dimension of B also. B also I want to find. So here in this equation I will substitute, that is F is equal to B t square. F is equal to B t square. So dimension of F is m L t raised to minus 2 is equal to B t's time already given, t square will come because dimension of time is t. So here cross multiplied, so we have m L t raised to minus 2 divided by t square equal to B. So t square is going up, so t raised to minus 2 will come. So we have t raised to minus 2 into t raised to minus 4. So I can write the equation m L t raised to minus 2, this is the numerator, into t square, which is the dimension of B. So t raised to minus 2 into t raised to minus 2 will be t raised to minus 4. So finally dimension of B will be m L t raised to minus 4. So we have already dimension of A, which is m L raised to half t raised to minus 2. So I am writing this m L raised to half m L raised to half t raised to minus 2. T raised to minus 2 is the dimension of A, and the dimension of B is m L t raised to minus 4. So we want to take the division of these two, that is A by B is equal to m L raised to half t raised to minus 2 divided by m L t raised to minus 4. So m cancelled and L raised to half divided by L. So it will be going up. So L raised to minus 1. So I am writing L raised to half into L raised to minus 1. Now this t raised to minus 2 into, in the denominator we have t raised to minus 4. It will be going to the numerator, so it will be t raised to plus 4. Okay, so here you have L raised to half plus L raised to minus 1, which will be minus half. So L raised to minus half into t raised to 2 will be coming. T raised to 2. So that is our answer, L raised to half t raised to 2. So I hope you understood this question also. Okay, let me go to the next question. So question, as you can see, the value of two resistors are 5.0 plus or minus 0.2 kilo ohm and 10.0 plus or minus 0.1 kilo ohm. What is the percentage error in the equivalent resistance when they are connected in series? So we have two resistors, both are connected in series, both will be connected in series. So we have to find its error, percentage error. So first resistor is 5.0 plus or minus 0.2. So plus or minus 0.2 means its variation. So second resistor is 10.0 plus or minus 0.1. So plus or minus 0.1 means its variation. That means it's a absolute error. Okay. So how will you do this example? So first of all, I have to add these two resistors. That is R1 equal to 5, then R2 equal to 10. That's the basic idea. So effective resistance R is equal to R1 plus R2, which is equal to 5 plus 10, which is 15 kilo ohm, which is 15 kilo ohm. Now absolute errors, sum of absolute error. So 0.2 is the absolute error in R1 and 0.1 is the absolute error in R2. So when you add these two numbers also, the error will increase. So we have to add the absolute error, that is delta R1 and delta R2 are the absolute errors in the first and second resistors respectively. So we have 0.2 is the absolute error in the first. So 0.2 plus 0.1 will be 0.3. So 0.3 is the absolute error. Now what is our next aim? Very simple, the percentage error we want to calculate. So percentage error will be the absolute error, mean absolute error divided by a mean into 100. That was a formula when we studied the theory. But anyway, that much we do not want to go. We have 15 and 0.3. So we can do directly, that is 0.3 divided by 15. 0.3 divided by 15 into 100 will be the percentage error. So this will be 15 into 100 divided by 15 into 0.3, which will be 2.